Hi guys. So today we're going to be looking at single displacement reactions. And in a single displacement reaction, one element in a compound is displaced or replaced by another element, producing a new compound and a new element. So this would be the general reaction. A plus BC produces AC plus B. So in this case, A would be the metal that would be displacing B, which would be the metal cation of the compound. And so B would be then all by itself, and A would become part of the compound with C. So an example of this would be copper and silver nitrate produces copper nitrate and silver. So in this case, copper displaced the silver. So how do you determine if this can actually happen? Because in grade 10 you learned that all reactions will happen, but now we see that this is not the case. We have to look to what's called the activity series of metals. So in the activity series of metals, and this is found on page 165 of your textbook, it's a ranking of the reactivity of metals relative to each other. So the ones that are higher up are more reactive. More reactive are at the top, and less reactive are at the bottom. So how would this work in the case of copper and silver nitrate? So I'm going to pull out the textbook, page 165. So I look at copper and silver. So I see that copper is indeed higher than silver on the activity series. This is why the reaction would proceed. The lone metal is higher than the metal in the compound. Okay, so that's how we use the activity series. So the activity series is based on two important generalizations, that metals displace other metals below them, but they can't displace metals above them. And the other part is that the farther apart the two metals are, the more likely that the displacement reaction will occur quickly. So that increases the speed of reaction. Okay. So we can use the activity series to help predict the products of a reaction between a metal element and a metal containing compound. So as I stated already, if the metal is higher on the activity series, the reaction will occur. If the metal within the compound is higher in the activity series, there will be no reaction. So in essence, the lone metal has to be higher on the activity series. So let's consider this following reaction. In this case, we have iron and copper sulfate. Iron and copper sulfate. So let's see, let's check our activity series. So we have iron is by itself and copper sulfate is in solution. Remember, that's what AQ means. So we look to our activity series. So in essence, iron has to be higher than copper on the activity series for the reaction to proceed. So let's take a look at our activity series. Is this the case? We have iron, and then way down here we have copper. So yes, this reaction will take place. So the iron will displace copper out of the compound to produce copper by itself as a solid. Copper as itself by a solid, as a solid, and iron will then come into the compound with sulfate. So common question is, how do we choose what is the charge in iron? Because iron is a multivalent element. So we will choose the most common charge. On the multivalent element. And how do we know which one that is? Well, we look to our periodic table for the most common charge. So I will look to the periodic table, and here in our periodic table it says the most common charge is the one that's higher up. So for iron, it happens to be the example here, it is 3. So we'll use that as the charge for iron. So if iron's charge is 3, that means we need a bracket around sulfate, and sulfate has a charge of 2. So that would be our compound, okay? Okay, so moving on now to this reaction. So we now have silver and calcium chloride. So we check our activity series for silver and calcium. So silver has to be above calcium for the reaction to take place. So take a look. We have silver and calcium is way up here. So in this case, there's no way that silver can displace calcium. So this reaction will not take place. So we need to indicate that as the following. You just say, we write no reaction, which indicates there will be no reaction taking place. And we state the reason. So when you're asked this on a quiz, you would say that since silver is lower on activity series. Okay? All right, so if we analyze single displacement reactions, so we will review the guidelines that we would look at. A metal will be displaced from a compound by a metal higher on the activity series. We treat hydrogen as a metal with a valence or charge of +1. We treat acids such as hydrochloric acid as ionic compounds, which of course they are not, in the form of H+ and Cl-, and we would treat sulfuric acid as H+, H+, and sulfate with a charge of -2. Any metal above hydrogen in the series will displace hydrogen gas from a dilute acid. And we treat water as an ionic compound as well with a formula H+ OH-. So here are some examples of some single displacement reactions involving metals. So in first case, we have copper and silver nitrate produces copper nitrate and silver. So again, we check our copper that it is higher up on the activity series. And so yes, it is copper and silver. So copper will displace the silver in this reaction. It will take place. We also have another example of a metal that is displacing hydrogen gas from hydrochloric acid. How do we know this happens? Well, we have a metal and an acid. This is our example of metal and acid from above. So we look to see, would magnesium displace hydrogen? So in this part here, we see magnesium. Yes, it would. So that this reaction would take place. If it was lower down, right, this reaction would not happen. So yes, magnesium would displace the hydrogen gas. And remember, see, now we have to make it H2 because it's hydrogen gas. It's diatomic. And lastly, we have sodium and water. And we saw this reaction when we did our reactivity lab. And so we see, does sodium also replace hydrogen gas out of water? We look to our chart and we see that sodium is on the list of displacing hydrogen from cold water. So this reaction would take place, and we took this water as H+ OH. So this is how we end up producing this is also called our hydroxide ion. And this is how we produce hydrogen gas. So this displaces the hydrogen, and we end up with sodium hydroxide and hydrogen gas being produced. Okay, we also can have nonmetals that replace a nonmetal anion in a compound. So this would be the general formula. The general formula would be plus F produces DF plus E. So the non-metal in this case is going to be F, and it's going to replace or displace the non-metal from the formula. So this is why E is all by itself now. Okay, so we can also see this happening, and this is when we displace halogens. So this is called displacing halogens, and we'll follow this on the next page. So how do we know if this will happen with the non-metal? We have to look to the activity series of halogens, and this is on page 167, but it's also just right on your periodic table. This follows the position on the periodic table. So you could see it here. I'm gonna show you in the corner. So there is the activity series, and it's the same as it is off the periodic table. So essentially it's just fluorine, chlorine, bromine, and iodine. So if you have your periodic table, that's all you need. So the more reactive, as we knew that fluorine is the most reactive non-metal on the periodic table from before. So the most reactive halogens will displace the less reactive halogens in reactions. So essentially, fluorine is more reactive than chlorine, is more reactive than bromine, is more reactive than iodine. So consider these reactions. So here's our first example. And we have fluorine and sodium chloride. So what would happen in this case? Well, we'd see is fluorine going to replace chlorine. So because fluorine is above chlorine on the periodic table, the reaction will occur. So our reaction would be as follows. Fluorine plus chloride, produces chlorine gas and sodium fluoride, and this is aqueous. Okay? In the next reaction, we have iodine and calcium bromide. So is iodine going to displace bromine? Well, iodine is at the bottom of the periodic table, so no, this reaction would not occur. So you would just write no reaction in this case. Okay, so we've got a few more examples here that we're going to work through, and then you can do some practice on your own. So we have a metal and an ionic compound, so magnesium and silver nitrate. So we have to look to our reactivity chart for magnesium and silver nitrate. So our silver, is magnesium going to displace silver? It sure is. Magnesium is way up, silver is way down. So this reaction will take place. So what will our products be? We are going to have silver, it will be on its own as a solid, and we will have magnesium nitrate. So this is where your nomenclature comes in handy and knowing your charges, being able to form your compounds. So this is going to be bracket aqueous. So this reaction will take place. Second reaction, we have lithium and sulfuric acid. So will this reaction take place? Well, we have to see, will lithium displace hydrogen? So look to our periodic table, and yes, lithium is way up there, very reactive, and it will displace hydrogen from an acid. So we will definitely have hydrogen gas produced, and lithium will come into the compound here, lithium sulfate, so Li2SO4. And example 3, metal and water. We have copper and water. So let's just see, will this reaction take place? You could probably think about it in life. Does copper really react with water? No, copper is way down here on the series, right? Copper is way down here, so this reaction will not take place. There's water. So no, not happening. So we write no reaction. I like to write reaction like this as a short form, RXN, okay? And lastly, we have chlorine and potassium iodide. So is chlorine going to displace iodine? Yes, sure enough it will, because chlorine is way up on higher than iodine on the periodic table. So this reaction will take place. So you've got iodine, which is a solid. It's one of the only ones that is a solid as a halogen, and potassium chloride aqueous. Okay, so you have a worksheet to practice. The next page is a worksheet, and so I'd like you to work on that and your homework questions from your textbook. So make sure that if you have any questions that you email them to Mrs. Vonar or myself, and we'll be on to our next lesson tomorrow. Take care. Bye-bye.